Last year, Chinese engineers created a robot brain that doesn't just follow commands, it predicts consequences, imagines outcomes, and corrects itself with a kind of intuition once thought impossible in machines. Now, China is field testing affordable humanoids that can learn and interact like young children, powered by this breakthrough AI. How close are we to a world where robots truly understand, not just obey, and what happens when they move from the lab to your living room? Inside a robotics lab in Beijing, the World-Omniscient World model, called Wow, runs on a neural network with 14 billion parameters, trained on 2 million real-world robot interactions. Instead of just watching videos, this system actively imagines what could happen next in the physical world. The process unfolds in a loop. A solver predicts a possible action, like reaching for a cup or stepping over a gap. Before any motor moves, a critic evaluates the plan, checking for physical plausibility and consistency with the laws of motion. If the move does not make sense, if the robot's foot would slip or an object would fall, the model refines the plan, cycling through the loop until it finds an action that fits both the goal and the rules of physics. This iterative predict, critique, refine cycle gives WeWow its edge over traditional AI. It is not just reacting to the world, it is internalizing cause and effect. On the WeWow bench, the system achieved over 80% adherence to physical laws, far ahead of video-only models. For the first time, a robot can simulate outcomes and self-correct before making a move, building a foundation for safe, autonomous behavior in unpredictable environments. Trust in autonomous robots hinges on more than technical benchmarks. For a machine to share public spaces or even homes, it must not only follow instructions, but also anticipate risk and avoid harm before it happens. Policy analysts in China now scrutinize how world models like Wow could fit into emerging safety regimes. Rather than relying on fixed scripts, these systems simulate dozens of possible futures in software, discarding any plan that might violate the laws of physics or safety protocols. This simulation-first approach is being weighed by regulators as a path toward more reliable certification. New draft standards call for robots to demonstrate not just task completion, but robust, physics-aware planning in unpredictable environments. Still, there is no official certificate for human-like intuition. Instead, approval depends on whether a robot can show, through repeated tests, that it can avoid collisions, handle unexpected obstacles, and recover gracefully from errors. The hope is that as these models improve, so will public confidence in their ability to operate safely beyond the lab. Noetics Robotics, a startup based in Beijing, set out to build a humanoid robot priced at just $1,370, less than a high-end smartphone. Achieving this required more than clever engineering. The team replaced expensive metal frames with lightweight composite materials, shaving weight and cost at the same time. Instead of buying motion controllers from foreign suppliers, Noetics designed their own control boards and motor drivers in-house, cutting out markups and giving them tighter control over every component. The company tapped into China's dense local supply chains, sourcing actuators, sensors, and batteries directly from factories in Shenzhen and Dongguan. By vertically integrating design and manufacturing, and leveraging the country's massive electronics ecosystem, Noetics managed to bring the cost of a fully articulated, classroom-ready humanoid below the 10,000 yuan threshold. This approach makes the idea of a robot in every home or school suddenly feel possible, not just as a demo, but as a real product within reach. Teachers in pilot programs have started using affordable humanoids like Bumi to lead coding lessons, demonstrate basic science experiments, and even help manage classroom routines. In some schools, students drag and drop commands on tablets, watching the robot mirror their instructions in real time, a hands-on way to introduce programming logic. While official records of mass deployment are scarce, Noetics' earlier N2 model reportedly reached over 2,500 units, suggesting a foundation for scaling up. The company's vision reaches beyond the classroom, and Bumi is pitched as a companion for daily chores, able to fetch items, tidy up, or entertain with a dance routine. For households, the prospect of a robot priced at $1,370 doing simple tasks is no longer science fiction. But as robots inch closer to ordinary life, questions grow about their impact on jobs and privacy, and whether families are truly ready to rely on them. A 35-kilogram humanoid, the Unitree G1, stood on a polished floor in Beijing, tethered to a sedan weighing 1,400 kilograms, 40 times its own mass. Engineers cued the start. The robot leaned back, shifting its center of mass behind its feet, and began to walk in reverse. Each step triggered precise adjustments across 23 joints, coordinated by the Thor whole-body control system. The sedan rolled forward, its tires gliding as the G1 maintained balance and traction, never tipping or staggering. This was not a test of brute strength, but a display of dynamic stability, proof that a compact robot could control its posture and distribute force with the kind of microsecond timing usually reserved for living muscles. The feat set a new benchmark for what small-scale humanoids can physically handle, hinting at a future where robots navigate real-world obstacles, not just lab floors. Site managers in China are already studying how robots with advanced balance could change the way dangerous jobs get done. The Unitree G1's ability to coordinate 23 joints in real time, making micro-adjustments dozens of times per second, could mean a robot that stays upright, showing remarkable stability on rubble, scaffolding, or wet concrete. Safety codes are being updated to account for machines that can sense a slip before it happens and recover on the fly. Regulators are drafting new guidelines for field deployment, weighing whether these machines can pass the same reliability tests as human crews. With these developments, the timeline for robots working in disaster zones or active construction sites is no longer theoretical, it is under active review. China's robots now learn and adapt in real time, at a price anyone can buy. As boundaries blur, the real test is not technology, it is trust. Would you let one in?